Hello, my name is Darryl Huften. I'm with the BCA. I'm here to talk to you today about pressure control zones, specifically tracking pairs. I'll talk to you a little bit about a general overview and some typical applications, as well as some commissioning strategies of how we can dial these systems in for long-term operation. Typically, a pressure control zone consists of a tracking pair. This can be a supply terminal and a return or exhaust terminal. The best methodology to control pressure in a zone is through airflow tracking. So one way to accomplish this is whenever my supply set point is at a certain CFM value, my return set point then becomes a offset of that value. So in this scenario, I have 800 CFM supplied and I have 700 CFM returned, and then I have a offset of about 100 CFM positive pressurization in this zone. Other things to consider is within these zones, we have, if you have a very critical zone that you cannot change your airflow measurement, and you want to make sure that you're constantly providing that offset, but you have a calibration sequence included with your airflow air crosses. You can actually use what's called an auto zero module for some manufacturers, or effectively a solenoid that will cut off the differential pressure, the velocity pressure reading at the controller, so that the flow cross sensor can actually do the auto calibration sequence without changing the position of the damper or effectively changing the airflow distribution to that space. Additionally, we often see that we have more terminals of service to these zones. It is not uncommon to see a fume hood in a system where you actually have pressure control. Typically, whenever there is a fume hood involved, that does require a pressure control zone, especially if it's a variable volume fume hood. And so what we see here is our fume hoods will operate in their own capacity, however they need to, based on sash position. And then our lab controller or our zone controller will actually adjust my supply and my general exhaust as needed to maintain the offset. You can kind of see a general sequence of operation here. There's a lot of notation here for tracking to maintain the offset. There's a couple different styles of terminal units we typically see in these zone pressure control scenarios. Typically, you can either see a traditional blade and damper, or you can see a Venturi style. Within the blade and damper, you'll use the airflow measurement to define what your airflow is. Within a Venturi, you can do an airflow measurement, or oftentimes you will see a position indicator. Now, the position indicator works on the spring constant, where you have the pressure from the amount of air that's flowing, or the pressure within the ductwork drives a plunger back and forth with a spring resistance force. And what that does is that changes the actual area around the plunger, which provides you a pretty accurate way of confirming airflow based on what the pressure is in this zone and what the actual air gap is here that the air is allowed to track across. Some traditional commissioning strategies. One thing to note is oftentimes these pressure control zones do require a very tight airflow measurement or tab tolerance when you're setting up a position indication style airflow tracking device. This means that we need to make sure that we do the proper test, adjust, and balance methodology, which would include traversing typically. This makes sure that we have the most accurate reading that we can pinpoint to either the K factor of our airflow measurement or the curve of our Venturi box. My rule of thumb here is typically when I'm going into a pressure control zone, the first thing I want to do is point to point each terminal. I want to make sure that I have all of the correct airflows set points, and I want to make sure that I have all the right operations of my damper and my airflow cross if that is the case. I also take a look at my my box settings. Now this is a standard TEC box setting that you can see here. These are the individual subpoints within that box and the settings that are associated with each zone and mode of operation. So next we do want to confirm the controllers at each mode of operation. This can include heating, this can include cooling, this can include occupancy. If there's a fume hood sash position indication, that is its own mode of operation that supersedes the heating and cooling typically. And oftentimes you can do certain gut checks with controller set point review, also having your balancer or take under the door DPs within each mode of operation. So here's another version of how you can kind of do a gut check of your set points. And then where your balancer can take measurements within each zone at the transfer air locations. Typically it's going to be under door. So within each one of these zones, I have a negative 100 CFM offset that is being transferred through the hallway space here. Lastly, what we want to look at, and we can look at more in depth on a later date, is the systems that serve these units. So typically these units are going to be very dependent on the pressure supplied to the ductwork serving these terminals. And so we want to be very cognizant of each zones or each mode of operation for the building as a whole. So, we can see that this is a lab building that has service from multiple systems. And so in our normal operation, we have one scenario. In our unoccupied operation, we see a slightly different scenario. Things are turned down, so there's a different flow profile and pressure profile through our system. And then we also have a lot of economizer mode operations, which requires a different understanding of how the zone air and supply air and exhaust air is going to be controlled. It's also very good to make sure you understand any failure scenarios. This can be a life safety shutdown or an emergency power mode of operation. How is that going to affect my zones? Within this system, we actually just maintain the laboratory at a very low flow through our hoods to keep each lab slightly negative, but also allowing for egress. This has been Darryl Huften with the BCA, going over pressure control zones and tracking pairs. If you have any more questions, concerns, reach out.